Good evening, everyone. We are in the week 2 problem solving session of the NPTEL course, Basic Electrical Circuits. And week 2 is about elements in series and parallel connection and control sources. So let me share my screen. In the beginning, I'll discuss a few aspects about the elements that are connected in series, if resistors are connected in series, if voltage sources are connected in series, what will be the equivalent or the final output, like the effective resistance or effective capacitance when few elements are connected in series or parallel. Then we'll move on to the control sources like current control voltage source, water voltage control voltage source, and what are how to understand them and how to solve problems. So initially we'll start with the basic series and parallel connection of elements. So first we'll start with the series connection, then we'll move on to the parallel connection. So for maybe half an hour or 40 minutes, we'll just revise through the concepts that were taught by sir in this week before we dive into the problem solving session. Then we'll solve quite a number of problems. So our concepts and fundamentals will be strong, and you can understand how to apply the concept that was learned through this entire week. So first we'll start with the series connection. So I can assume that you know what is a series connection. So if there are two elements, element A with terminals 1 and 2, I will call it A1, A2, and element B with the terminals B1, B2. So if one of the terminal of A is connected to one of the terminal of B, then they are connected in series connection. If the one terminals of element A and the two terminals, the second terminal of B, if they are connected together, then it is called parallel connection. So first we'll start with the voltage source. So there are multiple elements that we have studied in the previous week, like voltage source, current source, resistor, inductor, capacitor. All of them can be connected in series connection. So if they are connected in the series connection, what will be the effective resistance, inductance, voltage, or current? So that we are going to discuss. So first we'll start with the voltage sources. So some of the people are joining now. Let me admit them. Okay. Then we have voltage sources. Okay. So I'll connect multiple voltage sources in series connection. So let me consider few voltage source. Say this is one voltage source. This is another voltage source. This is another voltage source up to so on and such voltage sources. And I will name this as V1, V2, V3 up to so on Vn. So there are n such elements. Now, can you tell me what will be the effective voltage here? V effective. What will be the effective voltage? Hello, anyone? What will be the effective voltage if I consider this as a single element? So someone has mentioned, good evening, sir. Okay. Yeah, good evening, Gautami. And I hope I'm audible. Can anyone please answer this? Like, what if I have connected multiple voltage sources in series? What will be the effect, effective voltage? And I'll give you a hint. You need to apply KVL from this point to this point. So from this point to this point, you have to apply KVL. Sir, V1 plus V2 plus V3, V3. V3 is wrong. It is V1 plus V2 plus V3. And up to son Vn. Trishul, yeah, you are right. If there are three, then it will be V1 plus V2 plus V3. But there are n. So it will be V1 plus V2 plus V3 up to son Vn. So I'm writing down the effective voltage. V effective is V1 plus V2 plus V3 up to son plus Vn. So this is the overall effective voltage. So if I connect n voltage sources in series, then the net voltage source will be summation of these individual voltage source. I hope it is clear until this point. Now let us go to other aspect, which is the current source. We have also studied in our previous week that current source is also one of the element. So what happens if I connect multiple current source in series? So let me consider one such scenario where we have current sources connected in series. Okay, so this is our final element, and we are calling this I1, I2, I3 up to so on IN. So now can anyone tell me first of all whether we can connect it like this, or what is the issue by connecting like this? Can we connect this, or is there an issue, or you don't see any issue, or what is the I
Sir,
effective in this scenario? Yeah.
yes, sir, we can connect it, but they all should be equal because it violates KCL if they are
Yes.
not equal.
Yes, yes, very good, very good. And yeah, some of the people, Bhuvan and Roshan, they have also mentioned that there will be an issue, and it is only possible if all of them are equal. So this this connection cannot be made until I1 and I2 and I3 and up to so on IN are equal. So this thing is very critical. The basic point is you cannot connect current sources in series until they are equal. And if they are equal, there is no need to connect them in series, because if I connect two sources in series of 5 ampere, it is nothing but connecting a single current source, right? Because anyway, 5 amperes is going to flow. So that's why it is not a practice, not a good practice, and you should not also connect current sources in series. So this connection violates KCL. And you should also know is which law is getting violated, which is also very important. This connection violates this until or unless I1 is equals to I2 is equals to up to so on IN. So only when these currents are equal, then only you can make this connection, and else this connection will violate KCL, and you cannot connect current sources in series. So you should not also connect current sources in series. So till now we have connected voltage sources in series and then current sources also in series. Now we'll go to the elements that we know: resistor, capacitor, and inductor. So we'll start with the resistor. So let me consider one circuit where I have R1, R2, R3 up to so on Rn. Okay. So this is R1, R2, R3, and Rn. So one thing I forgot to tell you, that if I connect some elements in series, what does it mean? It means the current flowing through all of them is same. So all the elements will carry the same current. Similarly, here they are the current source, though the current that is being carried is decided by the value of that current source. Similarly, here resistors are there, so the current should be same through all the elements. So now we have R1, R2, R3 up to so on Rn. So can anyone tell me what will be the R effective in this scenario? R1, R2, R3 up to so on Rn. Yes, Roshan Ghosh, you have answered it correctly. So R effective is nothing but R1 plus R2 plus R3 plus up to so on Rn. R1 plus R2 and so on. Yes, Bhuvan, you are also right. So just similar to the voltage source, it will also be the summation of these individual values. If anyone has any query in this part, I'll explain you the proof. Sir has explained the proof already in the uh, his sessions. So I just skipped the proof, assuming that you have understood. If you have any queries regarding how this is coming, then I can explain you. And if you are okay with that, then we can proceed further. Uh, is this clear, or do you want me to explain how it is coming, or should we proceed with capacitors connected in series? Clear, sir. Okay. So if you have any question, please do not hesitate. Even if it's a silly question, don't hesitate. You ask me any question, I'll answer, and I'm here to address all your queries. So yeah, please ask if you have any question. And if you have not understood any part of whatever I have taught till now, you please point out. And you can stop me at any point. So if I'm explaining something, you can stop me, and then you can ask me question. Then I'll address your question. So then we'll move to capacitors. What happens if I connect capacitors in series? Okay, so let us consider n such capacitors, 1, 2, 3, up to so on n. Okay, so we have C1, C2, C3, up to so on Cn. So I am asking what will be the C effective. Can anyone tell me how we'll get C effective? Uh, yeah, someone said 1 by C1 plus 1 by C2. Bhuvan, yes, you are absolutely right. And others, do you agree with Bhuvan? Or you think some other answer is correct? 1 by C1, yes. Roshan Ghosh and Ibrahim, yes. So the overall effective capacitance can be obtained by this equation, which is, sorry, we'll use the same color, which is 1 by C effective is equals to 1 by C1 plus 1 by C2 plus up to so on plus 1 by Cn. And do you know why this is coming? How this is coming? So basically, we have to apply KVL, right? In the case of resistor, we have V is equals to IR. So we have to use here, we have to use this V is equals to I into R, whatever resistance. And using this and applying KVL, we will get the effective resistance expression. Whereas in the case of capacitors, what is the relation? We know I is equals to C into D voltage across the capacitance by dt. So individually, the current is same. So we have to add the voltages because we are applying KVL, and if they are connected in series, the overall voltage is nothing but summation of the individual voltages. So we know that V total effective is nothing but V1 plus V2 plus V3, and from this you can get the voltage expression, which I can also write it as, or if I have to write in terms of voltage, I will write as VC is equals to 1 by C integral I of t dt. And I is common in all of them. So it will be like on the RHS we have 1 by C1, 1 by C2, 1 by C3 up to so on 1 by Cn. On the LHS we have 1 by C effective. So that's how it is coming. Any queries, or is it clear until this point? If we have connected capacitors in series, what will be the effective capacitance? Yes, sir, clear. Okay. Then we'll move on to another element, the one element that is left, which is the inductors. So what happens if I connect inductors in series? Same thing. First, let me draw the inductors L1, L2, L3, up to so on Ln. Okay, so let me draw. So in the meantime, if you know the answer, you can mention in the chat box. Or if you want to speak, you can unmute and also tell me. I'll just check. Let me draw, then I'll check the answers. So we want the L effective. Yes, L1 plus L2 up to so on. Yes, Bhuvan, you are right. If others are typing, you can also enter the answer so that we can cross check. And it is very nice of you that you are very active and mentioning in the chat box. And if you answer, then only it will be more interactive and it will be interesting. So I'll ask few questions, then you can unmute and say if you are more comfortable. Also, you can mention in the chat if you are comfortable that way. So we have L effective. L effective is nothing but, yes, Gayatri Kumari, L1 plus L2 up to so on. You are also right. So we have L effective is nothing but L1 plus L2 plus L3 up to so on plus Ln. So this is the overall effective inductance when these are connected in series. So how we are getting? We know that VL across any inductor is nothing but L into DIL by dt, right? And we know that the current flowing through all these inductors is same. So summation of the voltages across the inductor is nothing but L1 plus L2 plus L3 up to so on Ln into dIL by dt, which can be written as L effective into dIL by dt. So L effective is nothing but L1 plus L2 plus L3 up to so on Ln. So until this point, is it clear? If we have connected multiple inductors or capacitors or voltage source or current source, what will be the issue in the case of current source, and in the other case, what will be the effective voltage, effective resistance, effective capacitance? Is this point clear? Until is this concept clear if we connect these things in series or parallel connection? I mean, only series, parallel connection is yet to be discussed. Is it clear for inductor? Kindly proof. Okay, so we'll prove for inductor. Then maybe if you have any queries, it will be addressed. So, do you agree that VL1 plus VL2 plus VL3 plus up to so on plus VLN can be written as total voltage? So, say this is plus minus VL1 plus minus VL2 plus minus VL3. This is plus minus VLN, and this is overall voltage plus minus capital V. So, do you agree? I can write this by applying KVL. Yes, sir. Okay. Now I'll use this formula and I'll substitute it here. So then what I'll be getting? I'll be getting, since the current is same and only the inductance is different, I'll get L1 into DIL by dt. Current is same because they are connected in series. DIL to DIL by dt plus up to so on plus Ln into DIL by dt is equals to V. So from this we'll get V is nothing but L1 plus L2 plus up to so on plus Ln into dIL by dt. So now if I consider this as my L effective, say this part if I consider as L effective, then I'll get as L effective into dIL by dt, as if all these inductors that are there, we are replacing it basically by single inductor who whose value is given by this expression L effective equal to L1 plus L2 plus up to so on Ln. So this I am writing it as L effective, and L effective value is nothing but L1 plus L2 plus L3. So all these inductors are being replaced by a single inductor. Basically what is happening is, now I'll have a single inductor with the value L effective, and L effective value is given by this expression, and that we are getting by using these IV characteristics of inductor and applying KVL. So is that clear? Whoever has query earlier. Sir, doubt in week 3, non-graded assignment. Vishwanath, week 3 is yet to be discussed. So this is week 2 session basically. So we'll be only discussing regarding week 2, and week 3 we'll discuss in the next week. So you have to wait until this session comes, because this week we are only dedicating it to week 2. If you have any query in week 1, then we can address. But week 3 we'll discuss in the next week. So yeah, please wait until we start week 3 so that others can also understand. The point is, it should be uniform for everyone. So week 3 we'll discuss in the next week. You please remind me whatever query you have in the week 3, then we can discuss in the next week. So till now we have discussed about the series connection, right? Now we'll discuss about the parallel connection. So elements can be connected in either series or it can be connected in parallel. Parallel connection. So in the series connection, what is same for all the elements? Current, because they are connected in series. In the parallel connection, what will be same? Voltage. So I will also write it down so that it will be easy for you. Series connection, we'll use it black color. Series connection, current remains same. Okay. And in parallel connection, voltage remains same. Okay, we'll quickly go through all these same elements. First, we'll do voltage source. So you can always correlate voltage source and current source. So current source connected in series is similar to voltage source connected in parallel. So you tell me, will there be any issue or is it fine? Because current source connected in series has an issue. Anyone? If I connect voltage
If they
source?
are not same, it violates KVL, sir.
Yes, yes, you are absolutely correct. Until V1 and V2, V3 up to so on Vn are same, you cannot do this because it will violate KVL. So I'll use the same and then I'll modify it there so that you can correlate nicely. So this connection violates KVL. So they are always analogous to each other. In the case of currents, it is the series connection. In the case of voltage, it is the parallel connection. And in the case of current source, it is the KCL. And in the case of voltage, it is KVL. So until all these are equal, you cannot connect. Until, sir, would you please prove me once again? So which part you want the proof? The resistor, capacitor, or which part can you please specify so that I can explain it again? Uh, Girikeshav, which part you have doubt? Can you please ask so that is it this part or is it the earlier part? Okay, so in the case of voltage source, if you connect them in parallel, there will be issue. They will violate KVL. If and only if they are equal, then only you can connect. Current sources in series violates KCL. Okay, so if we see this circuit, all these are current sources, and if you apply KCL, current entering should be current leaving. So if this is 5 ampere, this cannot be 10 ampere because they are flowing in the same wire. So if it is flowing in the same wire, current should be the same. So if I have multiple such current sources connected in series, then it means the current flowing through all of them should be same, else KCL is violated. So that which is what we have written. This connection will violate KCL unless these current sources are carrying same amount of current. If they are carrying same amount of current, then it will not violate KCL and you can connect them. But whereas in this case, voltage source same KVL, so the voltage difference across this element is same as voltage across this element. So unless V1, V2, V3 and up to so on Vn are equal, you cannot connect them in parallel, else they will violate KVL. So in the case of voltage source, it is parallel connection and KVL, and in the case of current source, it is series connection and KCL. So it is always analogous. So if it is voltage here, it is current there. If it is series here, if it is parallel there, something like that, you can always correlate. So I hope it is clear to you now, Girikeshav. If you have still query, you can ask. Thank you, sir. Okay. So now we'll move on to the current sources. So if current sources are connected in parallel, can you tell me what will be the I effective? So in the case of series connection, it is the voltage effective. Now in the case of parallel connection, it will be the I effective. I1. So if you know the answer, you please mention in the chat box so that I can check whether it is correct or wrong. So I1, I2, I3 up to so on IN, and we need I effective. I1 plus I2 plus I3 up to so on IN. Yes. Two people have answered, Bhuvan and Roshan. Yes, you are absolutely right. So we have I effective is nothing but I1 plus I2. Basically, you can apply KCL and say current entering is equals to current leaving, which is what we are basically writing here as well. So current entering is I effective current leaving is summation of I1, I2, I3 up to so on IN. Okay. Okay. So this is very straightforward and I hope everyone has understood. Then we can move on to resistors if you don't have any query. If you have any query, please ask me or you can mention in the chat box as well. So if we have resistors which are connected in series, then how are we going to get the effective resistance? So can you please mention in the chat box if you know the answer, what will be the effective resistance? Basically, these are very simple and straightforward. You have to apply KVL or KCL depending upon series and parallel connection, and then you just have to get the overall expression. And the proof sir has already explained, but I am just mentioning it again so that it will be like a summary and quick revision. So two people have mentioned 1 by R1 plus 1 by R2 and so on. Yes, Bhuvan, you are right. Uh, so in the series connection, it will be summation of the values, whereas in the case of parallel, it will be the summation of the inverse of the values. Yes. So we have 1 by R effective is nothing but 1 by R1 plus 1 by R2 plus up to so on plus 1 by Rn. So this is how, or this is what we will be getting as effective resistance. And how to get this? We know that the current and voltage relation is I1 is equals to V by R1 because the voltage across the elements are same. So I1 is nothing but V by R1. And we also know that current through all this will be I1 plus I2 plus I3 plus up to so on IN, right? Which is I effective. So that's how we will be getting. The voltage will remain same as I told, and currents will be I1, I2, I3 up to so on IN, and this will be I effective. So if you apply KCL, then you will get summation of currents on the RHS, which is V by R1, V by R2 up to so on V by Rn. On the LHS, we have V by R effective, so V will get cancelled, and you will get this expression. So is it clear until this point, or you still have any doubts? It is very simple and straightforward, and I hope it is clear. Okay, yeah, clear. Then we'll quickly move on to capacitors. So can anyone tell me what will be the effective capacitance in the case of N parallelly connected capacitors? So we have C1, C2, C3 up to so on Cn, and I am asking about C effective. So someone has mentioned C1, C2, C3 up to so on. Yes, Ibrahim, Roshan, and Bhuvan, Nadarajan, and Girkeshav. Yes, you all are right. It is the summation of capacitance. So we have C effective is nothing but C1 plus C2 plus C3 plus up to so on plus Cn. And how we are getting? We are basically applying KCL for all the capacitors, and the IV characteristics are given by I is equals to C into dV by dt. So I1 is equals to C, or you can directly say I. Now you have to apply KCL and summation of the currents. Then you will get C1 plus C2 plus C3 plus C up to so on. And you know that the voltage is same for all the capacitors. So RHS dV by dt will be common, and capacitor you have to add it. So it will be C1 plus C2 plus C3 up to so on and Cn. So this is also pretty straightforward, and I hope you are also clear with this. Now we will go on to the inductors. So if I have n such parallelly connected inductors, can you tell me what will be the effective inductance? If you know the answer, please mention in the chat box, or you can also say it. So we have here L1, L2, L3 up to so on Ln, and I'm asking about the L effective given the voltage is same because they are connected in parallel. So 1 by L1, 1 by L2, 1 by L3, and so on. Yes, Bhuvan and Girikesh and Nadarajan. Yes, this is correct. So we have L effective 1 by L effective. So let me write it properly. So we have 1 by L effective is nothing but 1 by L1 plus 1 by L2 plus 1 by L3 plus up to so on 1 by Ln, similar to resistors. So whatever is done there, we have to do the same thing here also. You have to apply KCL to the IV characteristics of all the inductors, which is given by V L. V is same, so V is equals to L into d IL by dt. Or you can also write it as, because we are dealing with the currents, so it will be IL is equals to 1 by L into integral V of t dt, and V is same because they are parallelly connected. So we have the terms in terms of 1 by L. So by applying KCL, you will get the term 1 by L1 plus 1 by L2 plus up to so on 1 by L on the RHS, and that's how we are getting the term. So I hope it is clear. Till now, we have discussed series and parallel connection of multiple such elements. We have started with the voltage source connected in series, then current source, which violates KCL if they are not equal, then resistors, then capacitors, then inductors. Similarly, when it comes to the parallel connection, we have connected voltage source in parallel, which will violate KVL, and it can only be connected if and only if all these voltage sources are equal. Then current sources, then resistor, then capacitor, and then inductor. So is it clear until this point, or you still have any doubt before we move on to the control sources, which is very interesting topic and also very important topic? Clear, sir. So if you have any doubts, you can ask. Else, we'll quickly move on to the control sources. So there are four control sources. If you have any doubts, you can please stop me. Controlled sources. So there are four sources, and this control source can also be called as dependent sources because the value of that source is dependent on some other value. So that's why they are called as dependent sources. Sir, how to calculate infinite resistance ladder problems? So, whenever there is infinite series, you just have to see and try to get that terms in terms of a geometric progression. And for geometric progression, you know that the summation for an infinite series, which is this. So, for an infinite series, GM, infinite series, geometric progression, GP is geometric progression. There is a formula that A plus AR plus AR square plus up to so on infinity is nothing but A by 1 minus R. Sorry, let me write this. A by 1 minus R provided R is less than 1. So this is a formula that you can use. So your aim is to get something of the infinite series in this expression so that you can use this formula, and then it's a finite value, so this infinite series can be converted into a finite value. So this is how you have to do. And in my last session I have answered one of the students queries, and the video is uploaded in the YouTube. You can go through that discussion and you will also understand how to solve that type of questions. Okay, there is less than a minute, so if this meeting end, kindly join back so that we can continue our discussion. So let me first write down what are the four such control sources. Sir, how can I get the notes of today's class? So let me mention three important links. Okay, I think I should copy again. So if this meeting end, kindly join back, then we can discuss. I am mentioning some links in the chat which you can use to access today's notes and today's videos and today meeting. So Bhuvan, I am mentioning the links, important links in the chat box. So there I have provided three links. One is to this Zoom meeting, and one is for the YouTube channel of mine where I'll be uploading this recorded problem solving session, and another one is the drive link where I'll be uploading the notes week wise, so you can access it from there. Sir, what can we do by control sources? So basically, control sources, one biggest application is BJTs and MOSFETs. So control sources are BJTs and MOSFETs where you can actually vary something by depending on the current and voltage of something else. So the control source can be either a voltage source or it can be a current source. So first, let me list down all the control sources. So first, we'll start with the voltage controlled voltage source. So first we have voltage controlled voltage source. Then we have voltage controlled current source. Voltage controlled current source. Then we have current controlled voltage source. Then we have current controlled current source. So this is also this can also be called as the abbreviation is voltage controlled voltage source, VCVS. This is VCCS. This is CCVS, and this is CCCS. So it can be either a voltage source or it can be a current source. Now it has to be controlled by another component which can be voltage or current. So there are 2 cross 2. So controlling element can be voltage or current, and source can be voltage or current. So the total number of possibilities are 2 cross 2, which is 4. So we have voltage control voltage source, voltage control current source, current control voltage source, current control current source. So now one of the student has asked, sir, what are the advantages of these dependent sources? So one way is, say I want a source which is varying, and I will not directly vary it. I'll use some other element to vary. So in that case, you can use these dependent sources. But the biggest application uh, is the transistors, where you can use them as an amplifier. So any MOSFET, or say MOSFET, it is a voltage controlled current source. So it comes under second category. So it is used as an amplifier, and it is having a very wide range of application. So these MOSFETs can amplify sound or any small signal. So the speaker that you are seeing, so now I am using a microphone. So this microphone will detect my sound waves, right? And it will be converted into some voltage signal basically. So now this voltage signal has to go through an amplifier. Say if I'm using a speaker and I'm talking to wide range of audience in a big auditorium, I am talking at a very low voice, but it is getting amplified, right? So who is doing this amplification? So there is an amplifier which you call and which you buy from the market, but this amplifier is nothing but a gain amplifier. So it is basically converting some voltage signal which contains audio information to some other voltage signal which is of a higher value. So it is basically amplifying the voltage. So now who does this amplification? There are some circuits made of MOSFETs, and that MOSFET is voltage controlled current source. So this is one very like real world application, and which you are very comfortable with. So the amplifiers, the speakers which basically amplifies this sound, so that basically what it does, it amplifies the sound signal. And now you have the control of volume, right? So this volume, what are you doing? You are increasing the volume, and that increasing the volume, what it does, it increases the gain, so that the sound will increase. So the quality or the sound of that signal is basically increasing. So when you are increasing the volume, basically you are increasing the gain. So how are you increasing the gain? You are changing something and something else is getting changed. So basically this amplifier, you will try to change something so that the gain will get affected. So something is changing and something else is getting affected. So some relation is there and it is dependent on something else. It could be voltage or it could be current. So this is one such application which you can understand comfortably, but there are many other applications where these dependent sources are used. So we'll go deeper into these circuits. Basically, we'll try to understand how the circuit looks like and some basic information about these circuits. So first, let me take this voltage controlled voltage source. Okay. So how the circuit looks like. So the voltage source value is dependent on some other voltage. So the circuit is something like this. And in the case of dependent source, we'll always use this rhombus or square shaped circuit, which means it is directly understood that it's a dependent source. Say this voltage is plus minus Vx, then this is some k times Vx. So the value of this voltage source is k times the voltage of some other element. So there could be circuit on this left hand side, and here there could be some circuit on the right hand side. But this value is dependent on this. Sir, how do we use control sources? Just now I have told Bhuvan, one application is the amplifier. So whatever I'm saying now, it is getting detected by this microphone. It converts my audio signal into some voltage signal, and that voltage signal is getting amplified. So in your laptop or mobile, whatever you are using, you have the increment in the sound, right? You can increase the sound. So basically, my sound will be increased. So there is a gain from my sound, my audio to whatever you are hearing. So there is some gain or amplification that is happening in between, which you commonly know as an amplifier. But in that amplifier, there is a circuit which amplifies the gain, and MOSFETs are used as a amplifier. And these MOSFETs are voltage controlled current source, and which is also one of the dependent sources. So and there is current control current source which is BJT. So it acts as a current source and that current is dependent on some other current. And why are they used? Basically these are some transistors which are used for many purposes. Say coming to your daily usage mobile phone, there are processors, right? These processors are basically made of MOSFETs, transistors, which you may often refer to as. So these transistors have like wide range of applications. Sometimes we need op amp. If you have heard of op amp, so current control current source is a BJT. So there is a transistor called BJT, and which may be a very advanced topic as of now, because this course does not consider that into syllabus. So this BJT, you can consider it as current control current source. And sir, some people want to admin the meeting. Sorry, I'm enter or what do you mean, Ramya? I'm not following. So if it is enter, whoever is asking for request, I'm allowing them in. So I have allowed whoever has asked for the request. So all these processors, whatever, it consists of some circuitry, say op amp or current mirror, which are again high level of topics. So this op amp, if you know op amp, so this op amp, how do we realize op amp? Op amp is realized using several MOSFETs, and MOSFET is voltage control current source. So these high level circuits, digital circuits or analog circuits, mainly analog, are they're in our day-to-day electronic devices, mobile phone, laptops, TVs, and these are having a building block. And MOSFET is a building block. MOSFET, some resistors, capacitors. So all these transistors are used as a building blocks for creating very big these circuits in our mobile phone and laptops. So amplifier is one such very like thing that we use widely in our day-to-day applications. And one such example I have told is audio amplifier, which amplifies the audio signal, and it will send to a speaker or whatever your laptop device or something. Okay, so this is voltage control voltage source, and here output is voltage, input is also voltage. So the K here, it is dimensionless because the output is a voltage and input is also voltage, and it is just amplifying. So it doesn't have any dimension. Okay. Now we'll move on to the second source, which is voltage control current source. So let me take this and use the same here. So we have voltage control current source. Got it? So how does it look? So it is again controlled by a voltage. So the LHS will remain the same, whereas on the other side we have current source. And I have told if it's a current source, dependent source, then we use this rhombus shaped thing. So that's why we are using like this. So it is Vx and the current is Gm into Vx because the output is current and the input is voltage. So what will be the dimension of the amplification factor? It will be conductance because I is nothing but G into voltage, conductance into voltage. And this Gm is called transconductance of this VCCS. So here Gm is transconductance of the voltage controlled current source. So it has dimension because it is converting some voltage into current. So that gain should have some dimension. Then only it can match, right? So that is having the dimension of a conductance, and that's why it is called transconductance. Similarly, if we go to current control voltage source, again it is converting some element or some quantity which has dimension to some other quantity which also has dimension. So there should be some uh, dimension for that gain that is being used. So now can you tell me what will be the dimension of that gain? So okay, let me draw then maybe. So there is a current flowing through some element, say Ix, and that is getting converted into voltage, a dependent voltage. So that's why again we have plus and minus. Okay, so the values I'm calling, say this is Ix, it is getting converted into a voltage. So has a dimension of volt and current is having an dimension of ampere. So what is the term that converts ampere or current to voltage? Resistance. So that's why this is Rm into Ix. And this is called trans resistance. Yes, Gagan, you are right. So this is trans resistance of the current controlled voltage source because the dimensions should match. So that's why the gain will have a dimension and the dimension is similar to that of a resistor, and that's why we are saying this. Now we'll go to current controlled current source. So which is our fourth source, and as understood the current is controlling another current source. So basically how we can draw, on the left hand side we have current, on the right hand side also we have current, and that is dependent on this value. So if this value is Ix, this will be K into Ix, right? And what will be the advantage of K? I mean, sorry, dimension of the K? It is also dimensionless because it is converting current into current. So that gain will have no dimension, and that's why K is dimensionless. So this is some introduction and some understanding about this current sources. So this is just an introduction and how this what do you say, this circuit looks like, but how to solve problems having these voltage sources and dependent sources, that will go on to now. So if you have any doubts, you can ask. Else we can move on to problem solving session. And today we have around 1 hour time, so we can solve many problems so that your queries will also be clear. Do you have any doubts till now in this part or the previous part? You can ask. Then I'll clarify your doubts and then we'll go. No, sir. Okay, anyway, let me just summarize what we have discussed in today's session. So we have started with today's session. Week 2 is basically about elements with series and parallel connection and these control sources. So first we have started with the elements connected in series: voltage source, current source, resistor and capacitor and inductor. And then we have moved on to the parallel connection of different elements: voltage source, current source, resistor, capacitor and inductor. And we have seen there are two cases. The first case being current sources connected in series, which will cause an issue because it might violate KCL if these current sources are unequal, having unequal currents. And similarly, the second case is voltage sources connected in parallel, and they also will violate KVL if these voltage sources are having unequal values. So these two connections should not be made, which are parallel connection of voltage source and series connection of current sources. So these should be avoided because they will violate KVL and KCL respectively. Then we moved on to some important topic called control sources. We have voltage control voltage source, voltage control current source, current control voltage source, and current control current source. So basically, what it is doing is this. We can say that on the LHS side, whatever we are having, it is the controlling element, and this is the controlled source. So let me just write, because something is controlling, right? On the LHS, we have controlling side, controlling and controlling element, or you can say anything, controlling side, I will say. And this is the controlled source. So this is being controlled, and who is controlling whatever is there on the left side. So voltage control voltage source means this is the voltage source basically, and it is controlled by another voltage. Similarly, I think we can use this voltage control current source. So basically this is controlling. So this is the controlling side and this is the controlled source. So this is getting controlled and this is controlling. So voltage controlled current source. Similarly, this is current control. This is the controlling side. Current control voltage source, because this is controlling this, right? So controlling side and controlled side, controlled source. Okay, controlling side and controlled source. Similarly, here we have controlling side and controlled source. So we have to move this here. Yeah. So this is controlling side and this is control source. So basically it's a current source, and this is getting controlled and this is controlling that. So that's why it is current control current source. So is this clear until this point? If you have any doubts? Sir, example of voltage controlled current source and current controlled voltage source. Voltage controlled, which one? Voltage controlled current source, current controlled voltage source. So, sorry. Why this has come? Okay, let it be. I'll check that later. So, in circuit, control side is connected in loop. Which control source? First, you have asked example of voltage control current source and current control, voltage control current source. So, MOSFET is one such example, voltage control current source. MOSFET, and current control current source is BJT. Current control voltage source, And voltage control voltage source, there are like not directly application, but you have to make some circuit like that. But these are the transistors that you are aware of, so that's why I'm directly telling. Okay. So one last question someone has asked, sir, in control circuit control side is connected in loop, which control source? I'm not able to understand. Can you please rephrase your question so that I can understand it better? So in the meantime, we can go to the problem solving session. So whoever has asked, kindly reframe it as it is a little bit confusing. So we have problem solving session, and we have 1 hour left, so we can solve many problems. Okay. So we'll start with the problem one. So determine the current in this figure below. So can anyone tell me how to proceed with this question? Anyone? How to proceed with this question? Any thoughts, any ideas? Don't give me the answer, just tell me the process.
6
Or
4 parallel with and series with 3.6. Then the whole combination is parallel with 4, sir.
yes. Okay, that is one way. So yeah, whatever you have told is good. So this is question one. Sir, R effective, apply Ohm's law. True. So first, what I will do is 6 and 4 are these things are connected in parallel, right? So first I'll call this R effective 1. Okay. So R effective 1, can you tell me what will be the value? 6 is connected with the 4. So what is the formula? R effective R1 and R2 are in parallel. Anyone? So 6K is R1 and 4K is R2. What is R effective in terms of R1 and R2? Anyone? What formula I have to use? So it is R1 R2 by R1 plus R2. Because we know 1 by R effective is nothing but 1 by R1 plus 1 by R2. So if you simplify that, you will get this. So this will be 6 into 4 by 10. So 24 by 10, which means R effective 1 is nothing but 2.4 kilo ohm. 2.4. Okay. I think someone has already mentioned in the chat 1 by 6, 1 by 4, 2.4. Yes. And Gayatri has also answered the overall current, which we'll check whether it is correct or wrong. So this is my R effective 1. So now I want R effective 2. So this entire sum I will do R effective 2. Let us call this R3 and this one R4. Okay. So now what is my R effective 2? R effective 2. Can someone tell what is R effective 2? Anyone? 6K. Yes, Chetan, you are right. So R effective 2 is nothing but R effective 1 plus R3, which is 2.4 plus 3.6 kilo ohm. So which is R effective 2 is equals to 6 kilo ohm. Okay. Now I will call this entire thing as R effective 3. Now what is R effective 3? R effective 3 is nothing but R4 and R effective 2 in parallel. So the formula says R effective 2 into R4 by R effective 2 plus R4. So once I substitute, I'll get 6 into 4 by 6 plus 4. So this is what R effective 3 is equals to, again, 2.4 kilo ohms. 2.4K, 2.4K. Yes, Akshata, Chetan, and Hema, you are right. 2.4 kilo. So now current is what? Voltage by resistance, 6 by 2.4. So which is what we have to do? 6 by 2.4. So I1, whatever they have asked, I1, I1 is equals to given voltage by R effective 3. So it is 6 by 2.4. So what is the value of 6 by 2.4? 2.5 milliampere. So 2.5 kilo, yes. So now we will get I1 is equals to 2.5 milliamperes. So I hope it is correct. If I am wrong, please let me know. So this is the overall I1 that is being supplied by the voltage source. So I1 is nothing but 2.5 milliamperes. Okay. So let us check 2.5 milliamperes. So it is correct. So let me just quickly revise or summarize what we have done in this question. So in this question, they have given some circuit, resistor circuit, and they are asking the current. So first, someone has suggested that, sir, we can simplify this entire resistor into single resistance. So we have started with this R1 and R2. So R1 and R2 are in parallel. So the effective resistance we have first initial obtained, and that initial effective resistance is in series with R3. So now this combined effective resistance is just summation of these two. Now we got R effective 2 is 6 kilo ohm. So now this 6 kilo ohm is again parallel with 4 kilo ohm. So now again I have two resistors connected in parallel. Now I have obtained the overall effective resistance which is connected with the voltage source directly. Now current is nothing but voltage by resistance V by R effective 3. So it is 6 by 2.4K, and someone has mentioned, many people have mentioned 2.5 million ampere. So Natish and Akshada and Roshan, they have said that it is 2.5 milliampere. So the current that the voltage source is supplying is nothing but 2.5 milliamperes. Okay, got it. So if you have any questions in this, any queries in this question, then you can ask, else we'll move on to other question. Any queries, or should we move? If you have any queries, please ask, or you can mention in the chat box as well. So someone has asked, no doubt. Okay. So now we'll move on to question two. So question two, they're asking what is the current I1, and here you see there is a dependent source. So dependent. So now is it voltage control voltage source, current control current source? Can you tell me? This is the first of all how to identify. It has a rhombus or square shaped symbol. So that is a control source. So it is VCVS. Roshan and Giri Keshav, they have mentioned. Yes, you are right. Because what is controlling what? It is Vx that is controlling. So that's why it is voltage controlled. And whether it is voltage source, current source, it is voltage source, because we have seen that they have mentioned plus minus symbol. So it is voltage controlled voltage source. So how to solve this? So first of all, KVL and KCL are still applicable, right? So first you have to calculate what is the Vx. So can you tell me what is Vx? Anyone? How to calculate Vx? Anyone? Any idea how to calculate Vx?
Vx is equal to 4 volts, sir.
Okay, and how did you get that?
Sir, they have given that voltage across 2 kilo ohm is plus Vx.
Hmm.
So, according to Ohm's law, we can assume that voltage across 4 kilo ohm is plus 2 Vx.
Okay.
Voltage drop is double.
Yes.
Or else we can solve it in another way, sir. Current passing through 2 kilo ohm and 4 kilo ohm can be given by Vx by 2k.
Yes. Yes. You are right.
Then we can apply KVL at
Yes.
a
Yes.
point. So that.
Yeah, you are right. So what he is basically doing is applying KVL. So let us assume the currents are I2 and I3. So now I can calculate I2 simply. How can I calculate? I will apply voltage upon total resistance. Total resistance is how much? 4K plus 2K. So it is 12 volt by 4K plus 2K. So now can you please tell me what is I2? Anyone from this calculation? Are you getting? So the voltage across both the resistance is 12 volt, and two resistors are connected in series. So the Effective is summation of these two. So 2 milliampere, yes, 2 milliampere. Yeah, you are right. 2 milliampere. So I got I2. So now what I have to do? I have to do what I have to do is I have to calculate Vx. So now can you tell me what is the value of Vx? So I know the current and I know the resistance value. Anyone how to or what is the value of Vx? Someone has drawn. Can you please erase that? 4 volts. Yeah. So whoever has drawn, please erase. I don't think I have the access to erase that. Please kindly erase that. Vx is nothing but I2 into 2 kilo ohm. So Vx will get as 4 volts, right? So Vx is 4 I2 into 2k. Yes, you are right. Everyone is right. So who is this 3? Can you please erase whatever you have drawn? Yeah, thank you. So Vx is 4 volts. Now what is the value of 5 Vx? Anyone, what will be the value of 5 Vx? 20 volt, right? Simple and straightforward. Yes, 20 volt. So now this is equals to 20 volt. So now can someone tell me what will be the value of I3? I3 I3 is voltage across that resistance 8k by resistance value. So can someone tell me what will be the voltage across this resistor? One, someone is mentioning, yes, 12 minus 20, Trishul, you are right. So I3 is nothing but voltage across that resistor by the resistance value. So now can you tell me what will be the voltage, sorry, the current value? Anyone? Minus 1. Yes. Trishul, whenever you are writing the answer, you should also mention the units because they are also very much important. I3 is minus 1 milliampere, right? So now can someone tell me why we are getting this minus? What is the meaning of that minus and what does it signify? What is a like what does it say? Minus and why we are getting minus?
Dependent source is delivering power, sir, but
Yeah.
I don't think actually it is possible practically.
Okay, yes. Current in the opposite direction, current assumed wrong, direction of the current. Yes. So basically, whatever whoever has said, I have not seen the name. So whatever he has said is, it is basically delivering the power. So the dependent source is delivering the power, and practically whether it is possible or not, that is not our concern. Anyway, it is a theoretical question. So that part we are not getting into currently. So you are right. So the current direction is opposite. Basically, the source itself is delivering the power. But anyway, I have the negative sign, so I'll proceed with whatever direction I have assumed, and I'll substitute with the negative value. So I'll not change anything in my assumptions. Sir, always in the circuit, the source with the highest potential delivers current. Yes, it is like that, but it does not always mean that it delivers current because basically whatever circuits that we are considering, it's a hypothetical circuit, right? So we are considering some hypothetical connections, and in this hypothetical situation, anything can happen. So a voltage source with higher value can or may or may not deliver the power. It may consume power or it may deliver power. So as far as theoretical questions are considered, we cannot make such assumptions until we get the current direction and voltage polarity. So we cannot make such assumption because this is a hypothetical question. In practical scenario, then we can apply the practical knowledge and these assumptions. But as far as theory is concerned, we cannot do that. So they are asking I1. So can someone tell what will be I1 in terms of I2 and I3? I1, I2, I3 relation. You can apply KCL, 1 milliampere. But I want in terms of I2 and I3, what is I1 and how is it related with I2 and I3? Anyone? Yeah, someone in
So
the chat.
I1 equal to I2 plus I3.
Yes, yes, you are right. So I1 is equals to I2 plus I3, and I2 is 2 milli, I3 is minus 1 milliampere, right? So I have to use the same convention because I3 direction I am not changing. So I will get I1 is nothing but 2 minus 1 milliampere, which means I1 is 1 milliampere. So basically, whatever current that they have asked in the question, it is 1 milliampere. So let us go and check. Yes, it is 1 milliampere and it is correct. So in this question, we have a voltage control. So I'll write it is voltage controlled voltage source. So they're asking what is the current. So initially we have to find out what is Vx. So how did we find out? First we got the current value. Then using that current we have found the voltage value. Now once we got this voltage value, we'll get this value. So now I know the potential difference across this resistor 8K. I can get the current by applying Ohm's law. Now I have obtained both the currents. If it is negative, let it be because my direction could be opposite. So I am proceeding with whatever assumption that I have made. And when I enter I3, I will write with the negative value. So I1 is nothing but I2 and I2 plus I3. So I2 is 2 milli, I3 is 1 minus 1 milli. So I1 is 1 milli and I have cross-checked with the answer and it is matching. So we can move on
सर
to,
excuse
yes,
me सर
yes, yes.
V5x is equal to 20 कैसे one
V
Vx
is
5
equals to,
Vx is equal to 20 sir
yes,
and
yes,
again the repeat sir.
yes, yes. So have you understood until Vx equals to 4 volt? Did you understand this step, how we are getting Vx equal to 4 volt?
Yeah,
Okay. So 5Vx is nothing but the gain or the value of this voltage source is 5 times the value of Vx and Vx is 4. So 5 times of 4 is 20 volt because it is dependent on this source. So if we go to voltage control voltage source, it is K
okay
times
okay okay sir.
Vx. Yes. So
Okay.
basically here K is 5, nothing but it is K times Vx and K is dimensionless. So that's why it is they have given 5. Got it?
Okay sir.
Okay, okay. So now in this question, if you see they are asking determine the voltage V1 in this figure. So first of all, I can see that there is a dependent source or a control source. Can you please identify whether it is a under which category it falls? Voltage control, current control, voltage source or current source? So
Voltage control current source.
voltage control current source. Basically, it is a current source and it is dependent on a voltage. So voltage control current source. You are very right. So it is voltage control current source VCCS. So now if we go back to voltage controlled current source, it is a transconductance, right? The gain is transconductance and the units are Siemens. So that's why they have given this dimension, right? These are the, again, there is less than a minute. So if this meeting ends, kindly join back so that we can continue our discussion with this prop. Dimension of conductance. Okay. If this meeting ends, please join back. Then we can continue our discussion. So they're asking determine the voltage V1. Any idea how to solve this problem or how should we start? If this meeting end, please join back. Then we can continue. Until then, we can continue our discussion. Any idea how or what how you want to proceed with this question? Anyone? Any idea? Yes, someone has mentioned, sir, first finding Vx, then we have to solve. Yes, for first finding Vx, I need to know the current that is entering into this branch and current division. Yes, so there are multiple ways you can solve this problem. So first I would like to find the voltage Vx. So what I'll be doing is first I will write the current direction. So this is one current direction, this is one current direction, and say this is Ix. So this is a current direction. So can someone tell me what will be the value of Ix? So this is 4 milli and this is 0.75 milli into Vx. So by applying KCL, can you tell me what will be the value of Ix? Apply KCL at this point. Anyone? Current entering equals to current leaving. So what will be the value of Ix? 4 minus 0.75 into Vx because it is dependent on Vx. Yes, you are right. 4 minus 0.75 into Vx. Yes, you are right. So it is 4 minus 0.75 Vx into milliampere, right? So I'll write milliampere. So now I know Ix. So someone can someone tell me what will be the value of Vx? Anyone? Any idea? What will be the value of Vx? Two Ix. Yes, 2 kilo ohm into Ix. So Vx is basically 2 kilo ohm into Ix. So I can write 2k into 4 minus 0.75 Vx into milli. So I can make kilo and milli will get cancelled. So basically what I'll be getting is Vx is nothing but 8 minus 1.5 Vx. So if I bring it back here, I'll get 2.5 Vx is equals to 8. So can someone tell me what will be the value of Vx here? What is the value of Vx? Anyone?
So 3.02.
3.2 or 3
3.2.
point? Okay. 3.2. So some people are mentioning 3.2 volts. Okay. So now I know Vx. And in the question, what are they asking? V1. So I know that Vx is equals to 2k into Ix. And V1 is equals to 3k into Ix. Agreed? Agreed? Yes, sir. Okay. So now what I will do is I will divide. So I'll get Vx by V1 is equals to 2 by 3 or V1 is equals to 3 by 2 into Vx. Agreed? Any doubts? Basically, I applied Ohm's law for this resistance and Ohm's law for this entire resistance. And now I got a relation between V1 and Vx because they have asked V1 in the question. So, did you understand how we are getting this? 3 by 2 Vx? Or do you have any query?
Sir,
Yeah.
here you added the two resistor, right, sir? 2
Yes.
plus 1, 3.
Yes. Yes.
3k into V1 equal to 3k into Ix. That's okay, sir.
Okay.
After that, Vx by V1 equal to 2 by 3. Can you explain that, sir?
Yes. So this is equation 1. This is equation 2. So basically what I have done is equation 1 by equation 2. So Vx by
Okay,
V1
sir.
on the LHS side is equals to 2 by 3. So now I got V1 equal to 3 by 2 into Vx. So can you substitute this here and tell me what is the value of V1? So someone in the chat box. Sir, please repeat last step. Please repeat it from the beginning. Yes, I'll repeat. I'll just enter what I am getting. Then I'll explain it from the beginning step by step. Can someone tell me V1, is it 4.8? Someone has mentioned in the chat box 4.8. Akshata, 4.8. Yes. So it is 4.8 volts. So V1 is 4.8. So our final answer is 4.8. So let us go and check whether our V1 is 4.8 or not. So answer says 4.8, so it is 4.8. Okay, so let me just explain from the very beginning. So first of all, this is the question. First, we have identified that it is voltage controlled current source. Okay. Then we have to find out what is the value of V1. So for this question, first we have to get the value of Vx. And for obtaining Vx, we need to know Ix because I know the resistance. So Ix is nothing but 4 milli minus 0.75 milli into Vx because we have applied KCL and current entering is equals to current leaving. Summation of these two is equals to this. So Ix is nothing but this minus this. So first we have obtained Ix. Then Vx is nothing but 2 kilo ohm into Ix. So 2 kilo ohm into this expression will give me Vx. So from this I have obtained one equation of Vx, and using this I have first initially obtained the value of Vx, which is 3.2 volt. So Vx is 3.2 volt, but in the question they have asked V1. So I need to know the relationship between Vx and V1. So I know Vx is equals to Ix into 2K and V1 is Ix into the overall resistance, which is 3K into Ix. So V1 is 3K into Ix. So I have divided these two equations. So Vx by V1 is equals to 2K into Ix by 3K into Ix, which is 2 by 3. So V1 can be written as 3 by 2 into Vx. Vx, if you substitute here, we'll get 3 into 3.2, which is 9.6 by 2, which is 4.8 volt. So V1 is nothing but 4.8 volt. So is this clear how we are getting V1? Whoever has said he has doubt, Roshan and Darunika, if you have any doubt. Yes, okay, I hope it is clear now. It is simple and straightforward. Yeah. Now we'll move on to another question. Question 4. Again, yes, question 4 we can solve. Yeah, we'll solve question 4. Determine the current in this question. Okay. We are in the question 4 now. So first of all, which control source they have asked here? Can someone explain or tell which control source is this?
Voltage control current source, sir.
Voltage control current source. Others agree with him? Voltage control current source. Yes. So it is voltage controlled current source. Similar to previous question. That's why it has also Siemens. So now they are asking what is the value of I1. Okay. First of all, can someone tell me what is the value of Vx here in this question?
4 volts, sir.
4 volts. So it is directly given. Vx is 4 volts. They have directly given. Okay. Now we have to know the value of this current, right? So there are how many control sources here? One or two?
2, sir.
Two. Yes. And this is one control source. And what about this? Which type of source is this?
Current control current source.
Yes, yes. This is current control current source. So the value of this is 3 into Ix. Okay. I don't know the value of Ix. Now I have to calculate the value of Ix. So can someone tell me what will be the value of Ix? Can I say that it is minus 0.5 millisiemens into Vx? Agree? Because the direction of Ix and this are opposite, but they'll have same magnitude. Do you agree? Yes, sir. Others,
Yes.
do you agree? Others agree or any query? Yes, sir. Okay. So now what is the value of Ix? What is the value of X? I'm not clear. Okay. Girikesab, so uh, we have a current source like this. Say this value is 2 ampere. And I'm asking what is this current? So this will be minus 2 amperes, right? So current flowing from right to left is 2 amperes, or current flowing from left to right is minus 2. So which is what we have done here. So current flowing is 0.5 millisiemens Vx from top to bottom, which means right to left. So if I ask what is the current flowing from left to right, it is having a minus sign. So that's why it is having this minus sign. So someone has mentioned minus 2 milli. Yes, Ix is equals to minus 2 milliamperes. Yes, sir, clear, sir. Okay, good. So it is having minus 2 milliampere. Okay, so now what is the value of I1? This is 3Ix and this is Ix. Agree? So this current is 3Ix and this current is Ix. Agree?
Yes, sir.
Now can you tell me what is the value of I1 in terms of Ix and 3Ix?
Minus 8 milliamps.
No, in terms of Ix I want. I1 is nothing but minus 3Ix minus Ix, right? Because all the currents are entering, summation of all the currents is 0. So I1 plus 3Ix plus Ix is equals to 0. So I1 is nothing but minus 3Ix minus Ix, which is nothing but minus 4Ix. So from this, we can get I1 is equals to minus 4 into minus 2 milliamperes, which means I1 equal to 8 milliampere. Agree?
Sir, I have one doubt, sir.
Yes.
Here. Uh, Here we know directly I1 is parallelly going means, so we'll take minus 3ix and minus ix, right, sir?
Yes.
Uh, in that 3ix node, can you please take the KCL, sir? Because the both the current sources in opposite direction, so I am not able to take alternate way to find if
Uh,
it's
can you please repeat it again? I could not
uh,
understand.
in that in that 3ix there is node
Node.
is there, sir.
Yes, this node.
Uh, yes, sir. In that, can you please take for KCL?
Okay, so KCL will give me current entering equals to current leaving. So we have I1
Yes, sir.
plus 3Ix plus Ix is equals to 0. So we have IN equals to minus 3Ix minus Ix.
Okay, sir. Okay.
Okay, got it.
Yes,
And
sir. Got it. Hmm.
yes. Sir, about current direction. Yes. So they have given the current direction. So Ix they are saying it is flowing in this way, and 3Ix it is flowing in this way. But when you see the values of Ix and 3Ix, it is coming negative. So basically current is flowing in the opposite direction. So with the values that we have obtained, what is the actual current direction? So the actual current direction is something like this. I1 is how much? 8 milliamperes, right? So basically, what is the current direction? Current direction is like this. 8 milliamperes is flowing like this. 2 milliamperes is flowing like this, Ix, and 6 milliamperes is flowing like this. Agree? I1 is 8 milli and 3 Ix is negative, which means the current is actually flowing in the other way. And Ix is also negative, which means the current is actually flowing in the other way. So this is 8, this is 6, and this is 2. This is the actual current direction, which can also be written as minus 6 flowing upwards, which can also be written like minus 6 milliamperes upwards or minus 2 milliamperes on in this direction. Both are same with a negative sign. So is this clear? Whoever has asked, Kunal Chaudhary, did you understand this question? Or let me just again summarize. So in these questions, we have two sources. One is a voltage controlled current source, other one is current controlled current source. So first we have to calculate this value, which is dependent on Vx. So Vx we have obtained. Then we have obtained the value of Ix. Then we have applied KCL at this node like this, and then we got I1 equal to minus 3Ix minus Ix, which is basically written here. So now basically we have substituted the value of Ix, and then we got the value of I1 as 8 milliamperes. So let us go back and see ampere 8 milliampere. So the question, whatever we have obtained, it is correct. So is this question clear? Question 4. Or do you have any doubts? Else we can proceed to question 5. Any doubts till this point? Clear, sir. Okay. Then we'll move on to question 5. So the more number of problems we solve, the more confident we feel, and it also less tendency of making any calculation mistake. So you have to solve more problems, then only you'll make less mistakes, because while solving you may make mistakes, so then you'll learn from your mistakes, and then you'll understand where you are going wrong. So 4 questions are done, right? Or 5 questions are done. So 4 questions are done. Then this is fifth question. So in this question, is there any dependent or control source, and what type of source is that?
Voltage control voltage source.
Yes, voltage control voltage source. And how to proceed with this question? Three Vx equals to 12, Roshan. So first we have to apply KVL. By applying KVL, you will get plus 12 volts. So I'm going from here and I'm going in this direction. So we'll have plus 12 volts minus 2Vx minus Vx is equals to 0. Agree?
Yes, sir.
Yes. Then we have 3Vx equals to 12 volt, which means Vx is equals to 4 volt. Agree?
Yes, sir.
So now can you tell me Vx in terms of I1? What is the expression for Vx in terms of I1? Apply Ohm's law.
4 by 2.5 kilo ohm.
Yes, that is I1. So Vx is nothing but 2.5 kilo ohms into I1. So I1 is nothing but 4 volt by 2.5 kilo ohms. So can someone tell me what is the value of I1? Anyone? 1.6. Yes, 1.6 milli. So you should always mention the unit. So 1.6 milliamperes. 1.6 milli. Yes. So let us go and check whether our calculations and our answer is correct or wrong. So let us go back. 1.6. So it is 1.6 milliampere. So let me just summarize how we have solved. First, we have realized that it is voltage controlled voltage source. Then we have applied KVL. So plus 12 minus 2Vx minus Vx equals to 0. So 3Vx is 12 volt, which means Vx equal to 4 volt. Now apply Ohm's law for this resistor 2.5K. So Vx is equals to current into resistance, which is 2.5K. So current I1 is nothing but 4 volt by 2.5K. So I1 is 1.6 milliampere. So is this clear until this question? Or do you have any doubts?
Yes.
Clear. Okay. So someone has mentioned in the chat box. Let me just address it. Sir, are there any resources we can refer to solve problems? There are some problems in assignment for which are not taught in lectures, and I'm not able to figure out how to approach or start the problem. So Sri Vishnu Vartini has mentioned. So one thing you can always see what reference book sir has mentioned, the professor has mentioned. If the professor has mentioned any reference book, then you can obviously go through that reference book, which is the best resource as far as my experience is concerned. So always go through some reference book where n number of problems will be there. You can solve. If not, then you can ask the professor in the forum, sir, kindly give us some reference book for this course so we can go through and solve more number of problems. So this is the first resource if you have. If you don't have, or if you don't want to go through a book, then the second resource is these problem solving sessions where we'll be solving more number of problems. And there are three TS, and we have talked to each other and made sure we will not be solving the same assignment. So I will be solving certain year assignment, and other TS will be solving a different assignment. So we all three will be solving different problems. Maybe the model will be same, but the numerical values will be different, and the problem is not the exact same problem. So you can see these problems and you can solve it by yourself. As I'm solving slowly, you can also think how to solve this, and you can also solve parallelly with me, which will again help you. So now we have solved five problems, and I think how much time is left? We can solve 20 more minutes are there, so we can solve two more problems at least for today. uh, then again, we'll have around seven problems that are solved today, and I have also revised a few concepts. So if there are any confusion in the concepts, then first of all, that was clear, and we have solved seven problems, which is more than enough, because we are solving different problems. So the main concept or the main objective is to understand how to solve a problem and what should be the approach to solve a problem. So even if you want to solve few more problems, which the other TS might explain in their problem solving session, then it is also fine. Yes, sir, but week one, same problem was solved in week one. Yes, Roshan Ghosh, actually in the week one, we have not met each other. And then after week one, we had a meeting with the professor, the course in charge for this, the on NPTEL course. We had a meeting with him, and then we had made sure that we will not be solving the same assignment. So I am solving 2018 year assignment. So other TS will not be solving 2018 year assignment. They'll be solving some other year, but the problem model could be almost the same. Say in someone is solving 2023, the problem might be same, maybe the values will be different. So the aim is we try to solve the past year assignments, so that in this year whatever questions are given, they will be see in the similar format. So you know how to solve this question. So even if I somehow twist, say in this question I will not ask I1, I will ask you what is the value of Vx, and I'll change these values, you should be able to solve. So that's what we are trying to achieve. Vishwanath, sir, I have a doubt. Can I share the image? Yes, you can send the image. But if it is from this year assignment, then I am not allowed to solve at this moment. Sir, about the notes of this class. Yes. So whatever notes, whatever questions that I'm solving, I'll be uploading it to my Google Drive, and whatever video that I am recording today, that will be uploaded to my YouTube channel. So there are three important links that you should always keep it with you. One is this Zoom meeting link, which is the meeting that you are joining every day, which is very important. And another one is my YouTube channel, where I'll be uploading this all my videos. And another one is this drive link that I am sharing, which to which I will be uploading my lecture notes. So you can follow through the YouTube channel. In the YouTube channel description, I'll be anyway mentioning the link to that particular week, so you can solve that. So Vishwanath has asked one query. So there is calculate V naught and calculate I naught in the circuit. So this will be our sixth problem. Sir, can you share device link? Device link, I'm not following. Which device link are you talking about? Drive link I have shared. You can click it and you can access. So someone has asked this question, calculate V naught and I naught in this circuit. So which we'll be solving as problem 6 for today. Yeah, so this will be our problem 6. So they have given a question, and they're asking, sir, what is the value of V naught and what is the value of I naught? Okay. So now basically what we have to do is we have to make some assumptions. So this is 200 volt, right? So I'll assume that current flowing this in is I1, current flowing in this is I2, current flowing in this is I3, and current flowing in this is I4. Okay. So I'll have 4 equations and 4 unknowns, right? Agree? I should have
But
4
it would be
equations.
complex if we take four variables.
Yes, it will be
Simpler approach.
complicated if we take 4 variables. But first of all, we'll get only 3 equations. How? I'll tell you. Can you tell what is the value of I naught here in
Sir,
terms of I1 and I2? Yes.
in this problem, we will use KCL, means it will be easily solved. Right?
Yes, yes. So that's what I'm doing. I'll apply KCL here and then I'll apply KCL here. So can you tell me what is the value of I naught in terms of I1 and I2? Apply KCL. I1 is
I
equal.
naught plus I2 equal to I1.
Yes. So I naught is nothing but I1 minus I2. So this is my first equation. Equation 1. So now I'll apply KCL here. So what is the value of I4?
Sir, where you are applying the
Here,
KCL?
here, here, here.
I3 plus I0.
I3 plus I naught, right? I3 plus I naught. So now substitute the value of that. I4 is equals to I1 minus I2 plus I3. So basically I4 is in terms of I1 and I2 and I3. So how many variables are there? 3 variables are there, right? Now it became 3 variables, right? Because I4 is dependent on I1, I2 and I3. Agree? Okay. Yes, sir. So now I'll apply KCL. Sorry, KVL. Say I'll consider this as my ground. Then this is 200 volt. So voltage across this is 200 volt. So we'll have 200 volt is equals to 70 into I1 plus 20 into I2. Agree?
Yes, sir.
Yeah. Now I'll apply again here 200 volt. So 200 volt is equals to 30 into I3 plus 5 into I4. I4 is nothing but I1 minus I2 plus I3, which is nothing but 5I1 minus 5I2 plus 35I3. Agree?
Yes,
Agree?
sir.
Yes. So now basically we'll write the number of equations and number of unknowns. This is my equation 1. This is my equation 2. So now what I'll be doing is I know something else, which is this voltage and this voltage are same, right? Both are shorted, right? Agree? Hello.
Yes, sir.
Yeah. So what is this voltage? 20 into I2. And what is that voltage? 5 into I4. True?
Yes, sir.
So this I can write as 5I1 minus 5I2 plus 5I3. So it is basically 5I1 plus 5I3 is equals to 25I2, which means I1 plus I3 is equals to 5 times I2. So from here you will get I3 is equals to 5I2 minus I1. Agree?
Yes, sir.
So we have how many equations? 3 equations, 3 unknowns. But again, still it might look complicated for you. So what I am going to do is I will substitute the value of I3 in this expression. Okay. So we have 200 volts is equals to 5I1 minus 5I2 plus 35 into 5 is how much? 205, right? Correct me if I'm making a mistake.
Sir, 175.
170.
Sorry. Sorry, yeah, 175 I2. So now this is how much? 170 I2 minus 30 I1. True?
Yes,
Yes,
sir.
sir.
Yeah. So now say this is equation 4. Now we'll write these two. So we have 200 volt is equals to 70 I1 plus 20 I2. And then we'll also have 200 volt is equals to 170 I2 minus 30 I1. So your first step, I'm writing step by step. So your first step is to solve for I1 comma I2 because you have two equations, two unknowns basically. So from four equations, four unknowns, we have slowly obtained two equations, two unknowns. Then what is your second step? Second step is the equation that we have here. I naught is equals to I1 minus I2. So once you have obtained I1 and I2, now you now you can calculate I naught, right? So calculate I naught. So you have to solve first these two equations, then you can calculate I naught. So once you have calculated I naught, then you have to calculate I3. How will you calculate I3? You have to use this equation, right? Again. So I'll use this equation and I'll solve I3. So my third step will be solve or calculate I3. Okay. Then fourth step will be calculate I4. And how will I calculate I4? I'll use this to calculate I4. And once I know I4, V naught is 5 I4, right? So my fourth step will be so this is my fourth step, calculate I4. Then my fifth step will be V naught is equals to 5 I4. Is it 5 or 4? Let us check. V naught is equals to 5 I4. Yeah. So is this clear how we have solved for this? Sir, can we use mesh analysis? Yes. Since I have not taught mesh analysis in this course till now, that's why I have not used mesh analysis. But yeah, you are free to use mesh analysis. Sir, any other method not possible here, like upper pair and lower pair resistance are in parallel? Can't we use R equivalent? No. If these two are yes, that also, yes, you are right. Yes, yes, yeah. Sorry. So these two are parallel. So this will have one equivalent resistance. These two are parallel. So it has one equivalent resistance. You can do. But the main like point that we are missing here is if you reduce these two resistance into one resistance and these two into one resistance, I naught is vanishing, right? Because in the question they are basically asking I naught. So that's why I did not try to reduce. If they have asked some current here, then what I would do, I will uh, write this in terms of one single R effective and my current I used to get I, whatever I they have asked, but that is not they have what they have asked. So that's why I'm keeping the circuit as it is and I'm trying to reduce everything into two equations, two unknowns.
Sir,
Yes.
uh, in this problem, we will put 3 KVL equation means it will be easily solved, right, sir?
Yes, yes, yeah. Three, see, anyway, you have to get three equations, three unknowns. Once you have three equations, three unknowns, you have to substitute one equation in the other one, which is what I have done. See, I have here three equations, three unknowns. And what did I do? I have substituted I3 in this. Then it became two equations, two unknowns. Something like that. So it's always three equations, three unknowns. From there, you will get two equations, two unknowns.
Okay, sir.
Okay. So basically, I'll just summarize what is discussed in this question. In this question, we have this type of circuit. First, I have assumed the currents. Then I have tried to apply KCL, and then I got I4 in terms of I1, I2, and I3. Then I have applied KVL in this branch and KVL in this branch. Then I have applied KVL in this branch and this branch. So we got three equations, three unknowns. I have substituted I3 in the second equations. Then I got two equations, two unknowns. You can solve for I1 and I2. Then I naught is obtained from this equation. And once I naught is obtained, I1 and I2 are known. You can calculate I3, then you can calculate I4, then you can also calculate V naught. So that's how you have to do, as this involves some mathematical simplification. I am not going into that. You can solve that for yourself, but this is the method that you can follow to get I1, I2, I3, I4, as well as I naught and V naught. Yeah, thank you, sir. And Sri Vishnu, you have mentioned few questions, and someone has also asked, sir, is there any problem? How should I approach? I just need a rough idea on where to start. Find V out between the potential difference. So if any question is there, so first you have to either apply KCL or apply KVL. Say you have asked one question here. Let me just take this. So this problem is there. So I'll tell you how I'm thinking so that you can also think in a similar pattern. So this will be question 7, right? Nodal analysis can be used, sir. Yes, nodal analysis. See, it's a problem which you can solve in n number of ways, and I try to solve in a way how I am thinking, and I what I think will be like small or a simplified version. So in this question, what have they asked? They have asked probably what is the value of V naught. Okay. So how will I solve? First of all, I will identify which type of source. Again, there is less than a minute. So if this meeting end, kindly join back so that we can continue our discussion. And I'll solve this problem before I end today's session. So please join back. If you have any queries, then you can ask. So is this current control current source, or which source is this dependent source?
Voltage control current source.
Yes, voltage control current source. And the value of current is nothing but 3 times V1. What is the value of V1?
3 volt.
Yes. So they have already given the value. So now what is the value of 3V1?
9
9
milliamps.
milliampere.
Yes. 3V1 milliampere is, if I think this meeting will end soon, please join back. 9 milliampere, right? So we got 9 milliampere. So I got the current. Okay. So now this is the value of current, and this is V output, right? So this is V output. So this current is going to flow in this resistor in this way. Agree? True or not? 9 milliampere.
Yes, sir.
Yes. So now tell me whether V naught will be at a higher potential or ground will be at higher potential, assuming this is the current direction. I'm asking whether V naught is at a higher potential or V naught is at a lower potential. Ground will be at a higher potential, right? Whoever is talking, your voice is completely breaking, and that's why I could not hear. So basically, V naught is what? V or V output. V output is minus 9 milliamperes into 3 kilo ohm. Agree? Basically, it will be if we apply V naught is equals to 0 minus this, because this is 0 volt, right? I am applying KVL. Agree? Agree? Whoever is following.
Yes,
Any?
sir.
Yeah. So now I'll substitute the values. So now you tell me what is the value of V output.
Minus 27 volts.
Yes, minus 27 volt. So whoever has asked, sir, how to approach. So in the question, first of all, any question, first of all, you have to see what they have asked. So in this question, they have basically asked what is the value of V output. But for calculating V output, I need to know the current. So I'll go step by step. So what they have asked, V output is what they have asked. But for calculating V output, I have to calculate the current. And how to calculate the current? They have given a relation and it is dependent on V1. So first I have to calculate V1. So that's why I have started with V1. Then I have calculated 3V1. Then I have calculated V output. So this is how I thought and how I have approached in this problem. Say we'll go to this problem. In this problem, they have asked I naught. So if I want to know I naught, I thought that I have to know the currents in each of these resistors. So first I have assumed I1, I2, I3, I4. Okay, and I have assumed that this is the direction of the current. So after assuming, how will I proceed? I know either KCL or KVL. So I know that I can apply KCL here, KCL here, which is what I have done. Then I know I can apply KVL here, KVL here, which means this loop. So let me draw. So I have applied KCL first in this loop. I mean KVL in this loop, and then I have applied KVL in the outside loop. Okay. Then I have applied KVL in this loop. So basically I am applying KCL or only KVL, but I am seeing where I can apply KCL, where I can apply KVL so that I can get more relation. And then I am just manipulating with the equations and doing. So someone has asked, sir, is there any use of 5 kilo ohm in this problem? No, it is just given. But if someone has asked, what is the voltage here, then you have to calculate 5 kilo ohm into 9 milliamperes. And yeah, here in this problem, whatever they have asked, no need of 5 kilo ohm. Sir, where is the positive terminal of V1 connected? So this V1, it is floating. They have not connected it anywhere. But this voltage is deciding the current in this. So if you go back here, it is an open terminal. Even in the case of here we are considering some open terminal. It can be open or it can be closed, right? So in some cases, Vx, it is not open. It is some circuit. It is a part of circuit, but it does not mean it should be a part of circuit. It can be open also. So here it is open, but it does not change anything. The value of current is dependent on this voltage. It can be open or there can be any resistance connected here, but still V1 is 3 volts, right? So it doesn't change anything. Okay, sir. Yeah. So yeah, that is today's
Sir,
discussion.
excuse me, sir.
Yes, yes.
Sir, sir. So, in V out, you have mentioned V out is equals to 0 minus 9 amp. How we got that 9 amp? I'm confused.
Yes. So if you see in this current source, 9 milliampere is flowing, right? In this 3V1,
Yes,
V1 is 3. Yes. So now if a current is flowing in this direction, it means it is also flowing in this resistor because here there is no path to flow because it's a terminal, just a terminal. They have named it as V out, but there is no path. This is the only path the current can flow. Agree?
yes, yes, sir.
Because this
Yes.
side there is no circuit, so the 9 milliampere that is entering here, it is coming through this resistor. So I have applied V output is 0 minus voltage drop across this, which is 9 milliampere into 3 kilo ohm. So V output is minus 27 volt.
Okay, okay, sir.
Okay,
Thank you.
okay, yeah. Yeah, Sri Vishnu Vardhini, today's session is almost over, and I would request you to solve by with this approach. First, you see what they are asking in the question, what current, what voltage they are asking in the question, and then you try to assume the direction of currents if they have not assumed, if they have not given, then you try to calculate one by one the currents and voltages by applying KCL and KVL. You have to know where to apply KCL and where to apply KVL, and they are pretty straightforward. And all these questions are very simple and straightforward. You just have to understand how to solve, and how to apply KVL, KCL properly. You should be very careful with the polarities plus symbol and minus symbol. If you mess up that one and then solve, then you will get a wrong answer. So yeah, it is very straightforward. Today we have discussed series and parallel connection and how to get the effective resistance, inductance, capacitance. And then we have solved some problems. But before that, we have also seen dependent sources or control sources. How many sources are there? What are the terminology and how to understand which source is what? And then we have solved few problems. If you see, they're very straightforward. It might look complicated, but once you apply KCL, KVL, and represent the circuit in a mathematical equation, then you just have to solve the mathematical equation. So all these circuits are basically a mathematical equation, but you have to write that mathematical equation. So the main challenge is writing that mathematical equation correctly. Once you write the mathematical equation, you just have to solve the equations numerically. So yes, that's it for today's session. You try to solve more problems. If you have any queries, ask in the other problem solving session. If you are still having any problems, then we can discuss in the next week problem solving session. Yes, with that we can end this session here.
Sir,
Yeah.
I have one small doubt, sir.
Yes. Yes.
In every week, we are solving around 40 problems
40.
for 1 week. For first week, we have solved 30 to 35 problems.
Okay. From where did you
So,
solve?
no, from this 3 session,
Okay. Okay. Okay.
right?
Yeah.
And then we solved our assignment problem also. Is it
Okay.
enough for final exam, or we want to solve more problem?
Yes, yes. So, see, whenever we are solving problems, it is just to assess our understanding of the concept. So, when you solve the problems, before that, you are going through the lectures. And once you go through the lectures, and if you see that you are able to solve the problems, then you should like feel that confidence that, yeah, whatever I have learned, I'm able to apply and solve the problems. If you are facing any difficulty, then you can solve more problems. Or if you want more confidence and more practice, then you can solve problems, but 30 40 problems in a week is just more than enough. So if you are able to solve all the problems and able to understand everything, and in the current assignment that is given in this year, if you are able to solve 80 to 90% of the problems, at least 70%, because there will be few difficult questions to just create the difference between the students so that there will be great distribution. But 70%, if you are able to solve with the concept that you have learned, then it should be enough. And the other 30%, if you are facing any difficulty, we are there to solve those problems. So once that deadline is over, then only we can solve. Before that, we cannot solve, as it is related to your grading, so we cannot solve that before the deadline is over. But once the deadline is over, then you can solve. If you ask, sir, what is the use if the deadline is over, it is not about marks. We are not giving you the answer for the marks. We are telling you how to solve that problem so that in your final exam also it will be helpful. So here we are solving few problems before the assignment ends so that it will be helpful for you to solve the assignment. And even if you are not able to solve few questions in that assignment, we'll solve that later so that towards your final exam you will have full clarity and confidence so that you can do it better. So we are here only to train you, teach you concepts better and solve problems for you so that you will gain confidence, and it will be easy for your final exam as well as weekly assignment. So we are here to always help you, but don't expect us to give you answers for your current assignments which is not correct. So apart from that, we are helpful, and again we are solving that assignment after the deadline. So uh, apart from that, apart from giving the answers to you directly, we are always there to help you and solve your doubts. And today meeting is past 2 hours, so whoever has asked questions in final like how to solve that problem, I'm not telling. But one question someone has asked, sir, what should we do if A and B terminals are not connected directly? So see, in this question, I there is first of all there is no question that here it is connected. Since A and B are not connected directly, they are two different terminals, so they have two different potentials. So you have to consider them as VA and VB, and VA is not equal to VB, and you have to calculate VA and VB. Only if and only if it is connected, then only both the potentials are same, else it is not same. Yeah, with that, we will end this session here. And I request you to solve problems. If you have any doubts, you can ask. I'll upload this video in the YouTube. If you have any queries, you can mention in the chat box. Currently, I'm on leave and I am not getting much time to reply to your comments. So I might reply within 2 to 3 days. But once my leave is over and I'll be active, then I'll attend react to your comments and reply to your comments quicker. But for the next 2 weeks, I am actually at home. I'll be at home and I'll be busy. So the delay will be there. You can expect some delay in the reply, but I'll reply to all the comments. And if you have any doubts, you can reach out to my mail ID or you can ask in the forum. Yeah, and with that, we can end today's session. And I wish you all the best for your weekday assignment. Try to do better, try to solve problems, and build confidence. Okay, with that, we can end today's session. Thanks for joining and thanks for being active and asking more questions and keeping it interactive. We'll meet in the next week. Okay, then, thank you. See you in the next week. Good night. All the best for your week 2 assignment.
Thank you, sir. Thank you.
Thank you.
Thank you, sir.
Thank you.